Can you guess why I chose this cartoon for a lecture about variables? Because the word variable, when we're talking about experiments in science, is something that can change. Notice it doesn't mean something that is changing, just that it can change. Some variables in an experiment we want to change, and other things we want to keep the same. And by the time you're done watching this lecture, you'll be able to pick out the variable that the scientist changes, the variable that changes because of what the scientist did, and the variables that you don't want to change. So there are two reasons why something in an experiment changes. Either the scientist themselves changes that variable on purpose because he or she is interested in what effect it has, or that variable is the effect and changes because of what the scientist did. Let me give you a simple example. Let's say I ask the question, does light cause plants to grow? To see if that's true, the variable I'm going to change is the light, because that's what I think is the cause. So the scientist is changing or manipulating what they think the cause is. The other variable I would expect to change in this experiment is the height of the plant. That's changing because of how much light I give the plant, or at least that's what I'm hoping to see. It might turn out that something different in the experiment changes, like the color of the leaves, or that nothing changes at all. But I picked an easy example so that we would already know the results to expect from that experiment. But if something else did change, that might lead us to ask even more questions. So in most experiments, there's three variables: the independent variable, the dependent variable, and the controlled variables. There are a few different ways to think about the independent variable. You can think of the independent variable as the cause. So in our previous experiment, light would be the independent variable because that's what we think is causing the plant to grow. Another way to think of it is what the scientist is changing. Again, in our previous example, to see if light is the cause, I would change the amount of light that the plant gets. You might also hear the independent variable referred to as the manipulated variable, because manipulated means changed. It's the variable that the scientist changed. There's another example below. A scientist makes an observation that some grass grows taller than other grass. And that causes him to ask the question, what causes the grass to grow taller? So the scientist decides to test whether nitrogen makes the grass grow taller. So let's make our question more specific now. Does nitrogen cause grass to grow taller? To test whether or not this is true, the scientists sets up an experiment, and they change the amount of nitrogen that's added to the grass. Some grass gets treated with extra nitrogen, and I say extra because there is nitrogen in the soil, and some grass doesn't get treated with extra nitrogen. The scientists will then measure to see if the nitrogen-treated grass grows taller than the grass that was not treated. In this case, the scientist thinks nitrogen is the reason grass is growing taller, and in the experiment, that is what they changed. So nitrogen would be the independent variable. The variable that changes because of what the scientist did is the dependent variable, because it depends on what the scientist does. In our last example, the height of the grass depends on whether or not the scientist added nitrogen to it. So in that case, the height of the grass is the dependent variable. Just like the independent variable, there are a few different ways that you can think about the dependent variable. You can think of it as the effect. If nitrogen is the cause, then the height of the grass is the effect. You can also think of it as the responding variable. The height of the grass responds to the nitrogen. It's also what the scientist measures. This idea might be a little bit tricky because the scientist can measure several different things in the experiment. They might measure how much nitrogen is added or how long they wait for the grass to grow, but they're always sure to measure the dependent variable because that will help them to answer their original question. If you want to know if nitrogen makes the grass grow taller, you need to measure how tall the grass is growing. Here are some more examples of questions a scientist might have. See if you can pick out what is the independent variable and the dependent variable. Make a chart like this one in your notes, where you have the question, the independent variable, which they remind you here is what I change, the dependent variable, which is what I observe, and then also include a controlled variables, and we're going to fill that in a little bit later. It's important in experiments that a scientist changes only one variable at a time. That way they can rule out anything else that might be causing the dependent variable to change. Think back to the experiment with nitrogen. Let's say you changed not only whether or not the grass got nitrogen, but you also used different types of grasses. Well, how do you know whether it was the nitrogen that made the grass grow taller, or one type of grass grows faster than the other, or needs less nitrogen than the other? You wouldn't be able to rule those out. In this experiment, you could change the type of grass that you used, but it's important that you keep them the same so you can tell whether or not it was the nitrogen that was really the cause of the grass growing taller. The type of grass is something you would want to control. There are many different things you would want to control in this experiment as well. You'd want to make sure that all of the grass receives the same amount of water and light, and that they're grown in the same temperature. All of these things could interfere with the experiment and cause changes to the dependent variable. Now go back to the chart you made on the last slide and list at least 3 controlled variables in each example. There could be many more than that, and there will be a wide variety of correct answers, but just pick 3.